There's evidence that as far back as 5000 BCE, Egyptian astronomers were recording the movements of Mars across the sky. There's no evidence that they had any idea what it was. An understanding of the planetary nature of Mars would come much, much later, in large part because that understanding required a great deal of other larger-scale contextual understandings to be formalized first. But they did seem to understand that it was different from the other lights in the night sky in some way. They noticed its retrograde motion, which basically just means it sometimes seems to move in the opposite direction of most other objects in the sky, and even included it in some of their ritual tomb-based artwork. The Neo-Babylonian Empire took this awareness a step further, into greater, if still far from complete, understanding by sometime around 600 BCE. They figured out a great deal about its cyclical behaviors and invented new arithmetical methods to adjust their predictions about where Mars and other planets would be in the sky over time. And at around that same time, the Chinese were figuring out the period and motion of Mars, among other heavenly bodies, which means, based on observation and math, they'd sorted out the movement-based relationship between these far-off objects and Earth. The ancient Greeks didn't do as much original work related to the planets as those other older groups, in part because they inherited so much information from the Babylonians, but they did formalize a few conceptions of how all these objects might fit together, which, though ultimately incorrect, did give them the chance to discuss and label these sorts of things more formally. One such name, Planeton, referred to the 7 then-known celestial bodies that didn't seem to behave the same way as all the other lights in the sky, and they developed a geocentric conception that put Earth at the center, with the Moon, the Sun, Venus, Mercury, Mars, Jupiter, and Saturn, those planets all named for gods in their pantheon, with the stars then further out from these other elements and fixed in space. Aristotle saw the moon cover up Mars back in 357 BCE, May 4th of 357 BCE, to be more specific, and that led him to believe that Mars was further away from Earth than the moon. This and other evidence was used to support the Greek conception of the Earth being surrounded by heavenly bodies, their size in the night sky, and movement relative to the Earth, telling us how close or far away they happen to be. There were issues with this model from the get-go, however, and though some of them were explained by a hacked-together concept called an epicycle, which attempted to explain away variations in motion by some of these bodies, including Mars, which seemed to conflict with the idea that they're orbiting at set distances, they eventually caught up with astronomers when, in the 2nd century CE, Ptolemy, a well-known thinker, philosopher, mathematician, and overall scientist in Rome-conquered Egypt, came up with a new model that accounted for a 40% increase in speed that was documented on one side of Mars' orbit, which prior models did not allow for. To do so, he had to arrange the order of these objects in terms of their theoretical distances from Earth, with the moon closest in, then Mercury, Venus, the Sun, Mars, Jupiter, Saturn, and then all the fixed stars behind them. Work continued on this throughout the world for thousands of years, with a lot of other interesting but also incorrect theories popping up. A lot of them based on good math and extrapolation, but with fundamental errors in the priors they were working from. And this continued until 1543 CE, when Nicholas Copernicus, a Polish mathematician and astronomer, published an initially not super popular work that over time gained acceptance, in which he claimed that the planets actually orbited around the Sun, the first formal, supported, heliocentric model of the solar system. This conception gained ever more support as further work by other astronomers confirmed much of what it contained, though there were still quite a few inconsistencies, including one involving Mars, namely that Copernicus's model presented Mars as having a circular orbit. About 50 years later, a German astronomer named Johann Kepler, working as an assistant for a Danish nobleman and astronomer named Tycho Brahe, was able to make use of Brahe's observations of Mars, which allowed him to come up with a variation of the Copernican model that had most things in the same places, but which gave Mars an elliptical orbit rather than a circular one. In the early 17th century, Kepler published a series of works that outlined his laws of planetary motion, which were a sort of upgrade to the Copernican model, which used a bunch of ellipses instead of circles, with Mars as the inspiration for that particular bit of vital planetary movement-related understanding. What I'd like to talk about today is Mars, our continuing exploration of it, our attempts to understand it, and what the future may hold for it. You're listening to Let's Know Things. I'm Colin Wright. If you're enjoying Let's Know Things, you might also enjoy my other podcast, Brain Lenses. Brain Lenses is about the multitude of variables that influence and distort the way that we see the world. You can subscribe to Brain Lenses wherever you get your podcasts, or you can go to brainlenses.com to read the collection of essays and listen to the archive of podcasts that have already been published. I hope you find some value in that if you decide to check it out. All right, let's get back to the show. With the advent of the telescope, a device that allows its user to see faraway objects up close, the amount of enhanced closeness determined by the quality of the device and its components, perhaps especially the lenses and mirrors used to magnify the light bounced off whatever the user is looking at. With that invention, astronomy entered a new era. And in fact, it was Galileo Galilei, an Italian astronomer and polymath, hearing about the telescope that led to a lot of the device's iteration, evolution, and popularity. He heard a rumor about a device that was being used for other purposes around 1609 CE, and quickly built his own version that he could use to observe celestial objects. And the construction on that was complete in 1610. It was another half-century before telescopes became powerful enough that astronomers using them could see more than a rough outline of the planets they were looking at. But in 1659, basic illustrations of the surface of Mars began to be published, and rotation periods, day-night phases, and confirmation of the planet's ice caps arrived in relatively short order after that. The next few centuries were awash with new details about the surface of Mars and the behaviors and properties of other planets and heavenly bodies. A great many moons orbiting other planets were also identified and named and quantified to varying degrees. Our understanding of the solar system increased in scope dramatically, but not as dramatically as it would a few hundred years later in the 20th century. In the early 1900s, there were quite a few holdover theories from earlier periods that stuck around, in some cases because they were neat and interesting to the average person, and thus were spread throughout the non-science vox populi fairly enthusiastically, and a lot of these were not taken super seriously by actual scientists, but others seemed to make sense based on what we knew about Mars, about other planets, and based on what we'd learned since the Industrial Revolution about science and technology and so on. Perhaps the most influential of these theories, which proved popular both amongst civilians and scientists, was the concept that some of the surface features on Mars that we could perceive through telescopes might be canals, and that implied some kind of life, perhaps even a thriving Martian civilization, building infrastructure in a way that we could recognize from all the way across that vast distance from the surface of our relatively newly industrialized Earth. There were quite a few astronomers, even at the height of canal fever, who maintained that the seeming structures we could see on Mars were actually just natural aspects of the Martian landscape. Yes, some of them seemed strangely straight and geometric and even organized looking if you peered at the photographs and drawings of the planet looking for signs of life, but the Occam's razor explanation was that these were simply ruts or valleys or canyons on the Martian surface, not large-scale industrial projects built by intelligent life. In 1909, improved imaging capabilities in our telescopes allowed us to see Mars more clearly and to see that the canals were actually just blotches of discoloration caused by natural features. But the rumor stuck around for quite a while after that, probably at least in part because it was fun to think about. Today, of course, we can be fairly certain that there isn't tech-enabled life, at least tech-enabled life as we know it, on the surface of Mars. We're far less certain about other sorts of life, and I'll talk more about that in a bit. But at this point, the surface of Mars is fairly well mapped, with at times very impressive levels of detail, and there are not, thus far, any signs of canals, buildings, antennas, the sorts of things that we would expect to see from a civilization like ours, if one was present on the surface of Mars. The space race between the United States and the Soviet Union, which kicked off in August of 1955 but then exploded into the collective consciousness of the world when the Soviet Union launched the first ever successful human-made satellite into orbit around Earth, the Sputnik 1, 2 years later, in October of 1957, led to a broad resurgence of interest in all things space. Things escalated quickly post-Sputnik, with competition for accomplishments in space seen by many as a proxy field of battle between two superpowers that might otherwise engage in actual, potentially world-ending physical conflict. This race, then, was both for scientific knowledge and exploration, but also to win hearts and minds around the world for their larger causes: democracy and capitalism for the United States, and authoritarian-led communism for the Soviets. In April of 1961, the Soviet Union beat the United States to putting the first man in space, followed by the first woman in space in 1963. There were quite a few other firsts in the early 60s as well, from spacewalks to the duration of launched flights, and most of the wins at this point were for the USSR, with the US generally seen to be lagging behind their communist superpower competition. Less than a decade later, though, by mid-1969, all that had changed, with the US achieving a milestone victory, putting the first human beings on the surface of the moon, and the USSR attempting to match that feat, but repeatedly failing, deciding to stick with in-orbit infrastructure building instead, which was seen by many people around the world to be a withdrawal from that larger competition in the face of their opponent's obvious victory. This, of course, is just a superficial conception of what actually happened during the space race, as holistically, the Soviets gave as well as they got in most regards, and their collection of firsts remains impressive. After that initial surge in interest, culminating in the race to put human beings on the moon, though, the race is said to have peaked, and by the early 70s, the US and Soviet Union began to collaborate on a few projects, leading to a fairly dramatic rendezvous between a US astronaut and a Soviet cosmonaut crew up in Earth orbit in July of 1975. The history of the space age, from that point forward, was a lot more collaborative, and though there are still divisions today, and perhaps more so right now than in recent history, that collaboration has seemed to benefit humanity, both in terms of diplomatic opportunities between countries and in terms of the amount of knowledge and know-how we all gained from combining resources and effort toward this collection of goals. During that heightened, relatively short period that we now call the space race, the up-close and personal exploration of Mars began when, beginning in 1960, the Soviets launched a series of probes, some for the purpose of achieving a hard impact, a crash landing on Mars, basically, and some focused on flybys to take readings and photos as they swooped by the planet. All 5 of those initial Soviet efforts failed, though, either because of launch or post-launch spacecraft failures. The first U.S. effort to make it out to Mars also failed when the craft did not separate from the launch vehicle. But the second U.S. effort, the Mariner 4, successfully made it to its destination in July of 1965, conducting the first ever Mars flyby. Most of the other efforts to make it to Mars until the next decade also failed. Both Soviet and U.S. rockets and vehicles had to be tweaked and upgraded quite a bit to make it out to such a far-off destination. The process is vastly more complex than even making it out to the also quite far, but nowhere near as far, as Mars moon destination that they'd been focused on until that point. The U.S. did manage a couple of other successful flybys in the 60s, though, and the Soviets finally got their groove back in the early 70s with a series of successful Mars missions, which resulted in several successful orbiters around Mars, and the first ever soft landing on the surface of Mars. The Soviet Mars 3 lander touched down on the surface of the Red Planet on the 2nd of December, 1971. And though it transmitted the first 70 lines of an image, contact was lost with the lander mere seconds after it touched down, so the image was left incomplete. The U.S. launched the Mariner 9 later than the Soviet Mars 2 and Mars 3, but it arrived earlier and thus became the first successful Mars orbiter. It also stuck around in orbit far longer than those other 2 Soviet efforts, over 500 days, compared to their 362 and 50 orbits, respectively. The U.S. Viking program resulted in a great deal more data from Mars than those previous efforts, due in part to what was learned from the Mariner program, and in part due to the advances in the technology that was being utilized. Both Viking 1 and Viking 2 projects had orbiter and lander components, and both successfully arrived at their destination, entered orbit, and landed on Mars. The Viking 1 lander consequently sticking around on the surface of Mars for 2,307 Earth days, which is over 6¼ Earth years, sending back gobs of photos, including the first complete photo from the surface of the planet, alongside all kinds of data about its environment and from experiments that it conducted on board, including a series of biology experiments focused on searching for evidence of life, 3 of which came up negative, 1 of which came up positive. And some scientists believe that this was either a false positive or it was caused by inorganic chemical reactions that were being detected in the soil. There were a couple of Mars-focused projects launched by the Soviet Union in the late 80s, but both failed, and the US's first Mars effort post-Viking program, the Mars Observer project, also failed. That was launched in 1992. The Mars Global Surveyor, though, which was launched in '96 by the US, succeeded and operated for over 7 years, and that paved the way for the Mars Pathfinder lander and the Sojourner rover, a rover being like a lander that can actually move around once it has touched down on the planet. So both of those were successful, but they happened around the same time as a bunch of failed projects by the relatively new Russian Federation, which took over when the Soviet Union collapsed, and by the Japanese Space Agency, and some other less successful projects by the United States. And that is actually a concise story of Mars exploration. It was pretty rough at first, and though we've had some massive successes, first by the Soviets with their early efforts, and then by the US with a flurry of orbiters, landers, and rovers, and of late by the European Space Agency, Indian Space Agency, and a combined effort between the EU and Russian space agencies. But despite those successes, the planet and the path to the planet is a graveyard of failed research efforts. It's just a very difficult place to go and to operate upon and around, if indeed you're actually able to reach it. That first rover was kind of a revelation for the US, though, and it shaped many of the program's future efforts. There's just a lot more that you can do with a mobile research base than with a static one. And though there is still plenty to learn from orbit and from a stationary land-based lander, some of what we want to know now can only be done accurately and with certainty from the surface of Mars, and with the additional capability of moving around once you get there. As of the day I'm recording this, there are 6 operational orbiters around Mars, one launched by the EU, one by the EU and Russia, one by India, and 3 by the United States. There is one lander operational on the surface of the planet, the InSight lander, which was deposited on the surface relatively recently in late November 2018 by the US. And there is one US rover still operational, the Curiosity, which landed on the planet back on August 6th of 2012. And that sets us up for the article that I'd like to unspool today. This piece comes from The Economist, and it's entitled, "Is There Life on Mars? A New Generation of Spacecraft May Soon Find Out." On July 20th, 2020, a spacecraft called Al-Amal, which is Arabic for hope, was launched by the Emirates Mars Mission from a launch center in Japan. This craft was primarily manufactured and developed in the United States, but it was funded and conceived of in the United Arab Emirates. And if it successfully arrives at its destination, which is Mars as planned, in February of 2021, it will study weather cycles, weather events in the lower atmosphere, dust storms, and the like, and variations in weather systems from region to region. The overarching goal of this probe is to better understand conditions on Mars, how and why drastic climate change occurred there at some point in its history, and why the Martian atmosphere seems to be leaking hydrogen and oxygen into space. This project has the added bonus of launching the UAE's earthly reputation as a spacefaring nation, which has certain soft power benefits, but has also been shown in other countries to help attract all sorts of talent and investment, while also nurturing and incentivizing local innovation and development of all kinds. A few days later, on July 23rd, the Tianwen-1, which is Chinese for heavenly questions or questions to heaven, was launched from a facility in China, also intending to enter Mars orbit in February of 2021. But while the Al-Amal is a probe that will conduct its research from orbit, the Tianwen-1 is a probe, lander, and rover. So the plan is to get it into orbit in February, then drop the lander to the surface in late April, with the rover emerging from that lander sometime shortly thereafter. There has been comparably little information provided to the international community about this mission, which isn't entirely unusual for China's space agency, which is intimately intertwined with its military, making secrecy fairly paramount. But the dribs and drabs that have emerged indicate that there will be an effort made to investigate the planet's environment and to search for evidence of past and potential current life, along with the implication that they're very interested in learning more about the distribution of ice on the surface of the planet and how the habitability of the planet has changed over time. Finally, there's the U.S. Perseverance rover, which launched on July 30th from a NASA launch pad in the United States, and which, though it's a near replica of the wildly successful and popular and strangely resilient Curiosity rover, the one that is still puttering around on the surface of Mars at the moment, there are also quite a few upgrades in terms of instrumentation, experimental modules, and an accompanying mini drone-like helicopter vehicle called Ingenuity that will allow the rover to more capably scout for locations to visit and explore down on the ground. Perseverance is also expected to arrive in February of 2021, and its main goal is to explore a massive crater that was a lake about 3.5 billion years ago for signs of ancient life. The concurrent nature of these missions is not happenstance. If planets had perfectly circular orbits, as was thought to be the case by ancient astronomers, the distance between planets would always be the same, at least if they were at the same point of their orbit. Because they're elliptical, though, and because they're influenced by other gravitational bodies, there is a decent tug on Mars by Jupiter, for instance, and because the orbits are not perfectly aligned on the galactic plane, with Earth sometimes being, quote-unquote, higher than Mars along that plane, and vice versa, there are times when Mars and Earth are closer, and times when they are much farther apart. The maximum distance between the two is about 401 million kilometers, which is about 250 million miles, while the minimum distance is about 54.6 million kilometers, which is about 33.9 million miles. These distances have decreased a little bit over the years, but they fluctuate due to all kinds of variables in general. That said, although 34-ish million miles is still a very, very vast distance, it's substantially less void to traverse than 250. That is something like 1/7 or 1/8 the distance, which is meaningful both in terms of time and in terms of resources, but also because in some cases there will be large gravitational bodies between the two, like the Sun. And although at times such distances in gravity wells can be useful, in most cases shorter distances are better when you're hoping to explore the inner planets. July 2020, as you may have guessed, is a shorter distance window. So these 3 missions being launched all at once is a practical necessity, not an indication of any kind of rivalry or competition. There are geopolitical implications here for sure, but this is not a space race situation. This is we need to launch during this tiny window or wait a few years for our next opportunity situation. In fact, there was originally meant to be a 4th launch during this particular window, a collaborative European Space Agency and Russian Space Agency project that includes a rover also focused on searching for past or present life on the planet, alongside a slew of other instruments and experiments. But the project was not ready on time, and as a result, it's been delayed until sometime between August and October 2022, which is the next available Earth-Mars short-distance window. The wait between windows is about 26 months. A couple of points about this collection of missions that I think are important to note and which may help paint a picture of the larger context in which they're taking place. First is that the search for past or present life on Mars has become even more pressing as we've learned more about our own global ecosystem, its ebbs and flows, and our ability to manipulate it, mostly for the negative thus far, but maybe for the positive too at some point. Hard evidence or definitive anti-evidence for life ever having existed on Mars would be useful information, but it's also useful in the sense that Mars is seen by many to be an extreme version of Earth. The 2 planets seemingly had similar setups, more or less, billions of years ago, and what happened between then and now is valuable information in helping us extrapolate about what could happen next on Earth. Beyond that, though, the more we learn about life in general, anywhere, the more we learn about biology as a whole. And if we can learn about life that evolved somewhere other than Earth, that would tell us even more, because there would be hard-set differences in the variables that stoked that evolution from what we're familiar with at this point in time. Second is that there are other objectives with all of these missions, alongside the stated climate and life-searching ones. The UAE stands to increase its global reputation and credibility, potentially building for itself a whole space sector, which is valuable in a lot of ways, including a great many earthbound ones. China has been aiming to get to Mars for about a decade, and their first mission, with booked passage on a failed Russian rocket, didn't make it. This new effort will test their capabilities to see how far they can stretch beyond their seemingly quite capable and sophisticated efforts in orbit around Earth and on the Moon. There are space race-esque undertones to their efforts in this regard, but the circumstances are quite different for many reasons, and thus it's probably most useful to view their efforts as internal milestones rather than anything meant to compete with the US or any other country directly. And the US still has quite a bit to prove in space, especially after many administrations' worth of slashing NASA's budget and a reliance on the space shuttle that limited us to Earth orbit for most of recent history. This is, in some ways, a bridge project between the way NASA has traditionally done things and the newer, increasingly commercially reliant version of the same, where the government entity is more entwined with commercial entities like Blue Origin and SpaceX, which may make them more capable and make their efforts cheaper, and thus perhaps more frequent, but which could also come with unknown, unwelcome baggage. There's no way to know. And it is somewhat telling that one of the few projects that made it through the most recent round of NASA cuts is a near copy of a very popular rover project that captured the public's imagination so completely. That may indicate that part of what NASA is looking for here is public support and brand polishing, alongside the obvious scientific benefits. A lot of other very interesting, compelling, potentially quite valuable projects were scrapped because of budget cuts and to make room for this project. Third, this is happening in the context of an increasingly crowded orbital space around Earth. Launching satellites has become nearly pedestrian at this point, and though it's still not cheap, it's getting cheaper seemingly by the day to launch stuff into space. The moon is also no longer barely tread hallowed ground. China's recent efforts on the far side of the moon, in particular, were quite impressive, and though we have yet to set up anything really permanent there, the infrastructure to do so is at least partially in place. Mars, then, has sort of taken up the mantle that the moon previously wore, as the nearest, most attainable, but still very difficult thing we could try to explore and understand and plant a flag on in the solar system. And fourth, there's the unavoidable, slow, steady, mostly behind the scenes, but not always, militarization of space that's occurring. The most recent instance of which was a fairly flagrant demonstration of space-based anti-satellite weaponry from Russia. In mid-July, it was reported that a Russian satellite, which in the past had been tracked, stalking a US satellite in orbit, which is very strange behavior for a satellite, that same stalking satellite deployed a projectile of some kind that destroyed another satellite. And this type of weaponry, although not entirely novel, in the sense that quite a few nations have demonstrated Earth-to-orbit anti-satellite projectiles in the past, most recently India back in April of 2020. Despite all that, it was still a bit of a shock to the international community, because space, thus far at least, has remained officially unweaponized. It's a fair bet that there are weapons up there from all kinds of nations and potentially other entities as well, but no one has made overt use of them until now, which makes sense because destruction of in-orbit assets could lead to all kinds of problems, both for the people and countries that rely on those assets, but also for humanity in general, as it creates more in-orbit debris, which can then prevent or damage future orbital projects or future missions to Mars and elsewhere that then have to try to navigate their way through a growing, potentially cascading cloud of dangerous, super-fast, bullet-like garbage that's being flung endlessly around the planet from these destroyed assets. There's a good chance that this was intentional posturing on Russia's part. They tend to do that sometimes as part of the government's internal reputation management and as sort of a thinly veiled threat to potential external enemies. This is part of why even peaceful activities in space can sometimes seem menacing, though. It's difficult to know who is doing what, why, and what their intentions might be long term. Fortunately, for the time being at least, humanity's efforts related to the Red Planet, despite the God of War implication of the name Mars seem to be some of the most peaceful and collaborative international activities that are happening within any realm of inquiry, on the planet or off, at the moment. If you're enjoying Let's Know Things, consider becoming a supporter. One of the simpler ways of doing so is becoming a patron at patreon.com/letsknowthings. Committing to any amount each month will net you an additional episode of the show each month. There are also other ways to support the show, though, if you're keen, from one-off monetary contributions to non-monetary contributions. You can find a list of those at letsknowthings.com/support. The book that I'd like to recommend today is called The Book of Coley by M.R. Carey. I picked this book up because it had gotten some pretty solid reviews, and the concept behind it seemed fairly compelling. It's set in a future UK after some pretty bad dystopian stuff happens, and humanity as a whole is struggling to keep things together and survive within the context of a world in which their ancestors had genetically engineered trees and other plant life to try to make them more efficient and effective. The outcome of which is that plants, in particular trees, have become essentially predatory, and thus the surviving humans are more or less stuck behind walls doing what they can to try to avoid essentially all of nature that wants to and can very easily destroy them. I think two of my favorite things about this book, though, and there will at some point be further books in this series apparently, and I'm very much looking forward to those, is the world building and the narrative style. The narration being from the standpoint of a villager in one of these little walled towns that is just barely managing to survive within this context. And the world building being the slow drip, drip, drip of information about what happened to get the world to where it is in this story, but also about that world as it exists in the current day in this story. Both are very, very well done, and it's a very compelling read. The type of book that I had trouble putting down, actually. So if any of that sounds interesting to you, consider picking up a copy of The Book of Coley, K-O-L-I, by M.R. Carey. You can find out more about me and my work, including the books that I've written, at colin.io. You can find the show notes and transcript for this episode and every episode of the podcast at letsknowthings.com. You can find my other podcast at brainlenses.com or by searching for Brain Lenses wherever you get your podcasts. You can find my blog at exilelifestyle.com, and feel free to reach out and say howdy on your social network of choice. I'm Colin Wright on Facebook and at Colin is my name on most of the other ones. Thank you so very much for listening. I'm Colin Wright, and I'll talk to you again next week.